this is the last section for this unit, so the last part for the geosphere. We're going to cover chapters 9, 8, 10, and 11 for this unit. We're going to start with chapter 9. So 9.1 and 9.2, continental drift and plate tectonics. So what is continental drift? It's the hypothesis that Alfred Wegener came up with. And his hypothesis stated that continents had once been joined to form one single supercontinent. So instead of having our 7 different continents that we have now, everything was put together as one big landmass. The supercontinent he named Pangaea. And he said that the Pangaea had began to break apart, move around about 200 million years ago, and that is what has formed our land masses today. So if you look at the image, you can see here is the one big landmass. Okay, everything's kind of moving. You can see the red arrows. So about 200 million years ago, here's the start. 130 million years ago, you can see there are definitely some more spaces that have split up. Then 70 million years ago, you can see more of our continents today taking shape. And then, of course, today, you can see all of our continents in their respective places. This is another image of what you might see as Pangaea, and you'll need to keep this image in mind and probably come back to it when we do our activity in class. So, the breakup of Pangaea, and you can see this, it started out with Pangaea, then it split it up into Laurasia and then Gondwanaland. And then, of course, that split into what we have as North America, Europe, Asia, Africa, South America, Antarctica, Australia, and India. And now, of course, India has joined in with Europe and Asia, and we have now also split those up into what we call plates. So the tectonic plates, and we'll look at those in just a few minutes. So what evidence is there for the continental drift, or Alfred Wegener's hypothesis that there was this huge supercontinent that first existed? Well, the first is the continental puzzle. So how all of our continents kind of seem to fit together. Matching fossils is another thing. So across continents, so let's say in South America and in Africa, there are some of the same fossil organisms found in both of those places. And these are fossils, or these are organisms that could not have spanned the ocean that's now between those two continents. And then, of course, the other is rock types and structures. So specifically mountain belts and the types of rock that makes up a mountain belt. They might end at one coastline of a landmass or of a continent and appear on another landmass that's across the ocean. And then, of course, ancient climates. So again, how all of our continents seem to fit together. You can see from the image in the bottom, those are our matching fossils. So if you look here, this is one that spans from South America to Africa. The Triassic period had a fossil that spanned Antarctica, India, and Africa. The one that spans all of them is actually a flower. It's a fern. And then the most commonly known is the Mesosaurus, and that was found across Africa and South America. Ancient climates, you can see Antarctica, of course, is now our really cold area. But what used to be cold was everything in the middle here. So how our climates have changed. And then, of course, matching mountain ranges. Our Appalachian Mountains that we have that spans from the northern part of Georgia all the way up into Maine and into parts of Canada actually connects with with a matching set of mountain types, like rock types that are in that mountain, and they are built in the same structure as what's on the British Isles and in the northernmost parts of Europe and Asia. So this is what it probably looked like before everything split, causing this rift between the full mountain belt itself. So Wegener's hypothesis. He couldn't explain what made the continents move. He just knew that for some reason they did. Now, new technology, especially as we progress in today's times, that has led to more and more findings that support a new theory, so not what Wegener had, but a new theory for plate tectonics. So Wegener's hypothesis was rejected. So what does plate tectonics say? The plate tectonics theory talks about the uppermost mantle and the overlying crust. So think about the lithosphere. Okay, that's that part. We talked about that from chapter 1. And it moves over the lower mantle, which we call the asthenosphere. So it's that molten area. So for example, here's your lithosphere. You have continental lithosphere, oceanic lithosphere, and you have this very upper portion of the mantle, and then you have the lower portion. So when magma rises up from the mantle, you're going to get all of these different plate movements, and we talked briefly about that in previous chapters, but different plate movements based on where it is coming up from. So what is a plate? And I'm not talking about a plate you eat on. A plate is a rigid section of lithosphere, and it moves as one section over the asthenosphere. And there are numerous plates that we have. Some of the more common, the Pacific plate, that's the largest. We have the Australian plate, the Eurasian plate. We have a North American plate, a Caribbean plate, an Antarctic plate. We have other things. We have a Philippine plate. We have a Fiji plate, an Arabian plate. So it's not necessarily what the continents are named, but based on where they are, they have pretty similar names. Now, India, you can see India is over here in this Australian plate range. India actually used to be its own individual landmass and has moved itself into the Eurasian plate, or into Europe and Asia, and that has actually created the Himalayan mountains. So, because we're talking about how these plates move and how things are getting farther apart or closer together, we need to talk about the types of plate boundaries. So we have divergent, that's where they're moving apart, they diverge. We have convergent, so they're coming together. So those are moving together. And then we have what's called transform fault boundaries. And this is where they're kind of grinding past each other without producing any new lithosphere or destroying any of the current lithosphere. And you can see that in the bottom image. So for today, read 9.1 and 9.2 in the Earth Science book, 3.3 in your environmental book, and then do 9.2 handout. We are also going to start work on our Pangaea activity today. And that's it.